Now we will talk about nitrogenous bases in DNA and RNA. As everybody knows, there are 4 nitrogenous bases in DNA: adenine, thymine, cytosine, and guanine. According to the number of rings, it can be classified as purine, 2 rings, and pyrimidine, 1 ring. Pyrimidine is thymine and cytosine, while adenine and guanine are related to the purine. The purines on one strand of DNA form hydrogen bonds with the corresponding pyrimidines on the opposite strand of DNA, and vice versa, to hold the 2 strands together. Within DNA molecules, this is their most important function, and it is known as base pairing. This complementary pairing occurs because the respective sizes of the bases and because of the kind of hydrogen bonds that are possible between them. It means that adenine pairs with thymine with 2 hydrogen bonds, while guanine pairs with cytosine with 3 hydrogen bonds. There we also can mention Chargaff's rule, which states that the amount of adenine is equal to the amount of thymine, as well as the amount of cytosine and guanine is equal. In addition, in a double helix structure, the strands of DNA run antiparallel, meaning the 5 end of one DNA strand is parallel with the 3 end of the other DNA strand. The nucleotides forming each DNA strand are connected by non-covalent bonds, called hydrogen bonds. Considered individually, hydrogen bonds are much weaker than a single covalent bond, such as a phosphodiester bond, but there are so many of them that the 2 DNA polymers are very strongly connected to each other. It also should be mentioned that in RNA the thymine is substituted by uracil, which is a demethylated form of thymine. So uracil is one of the 4 nitrogenous bases in the RNA that are represented by the letter U. In RNA, uracil binds to adenine via 2 hydrogen bonds. It means that uracil is also a pyrimidine.